When we talk about end behavior, what we're talking about is basically what does the function behave like, or what does it do as x gets really large or as x gets really small. So as x approaches infinity, so getting large, millions, billions, trillions, and so on, what does the graph sort of behave like? Like, where does it go? Does it approach a certain value? Does it scream up towards infinity on the y-axis as well? Or does it level out, or does it go down? What is the end behavior like? And more specifically, what we're talking about in this class is where does the graph sort of end, right? Which quadrant does it end in? The values it approaches and that sort of thing may be more directly a calculus kind of thing. But here I have on DESMOS, here I have y equals x, right? That's y equals x. And I've denoted over here y equals x to the power of 1. I'm going to change this w value. I'm going to change it now to 2. So watch what happens to the graph when I change it to 2. Okay. And there's 2. So what shape is this? That's a quadratic. That's a parabola shape. It's a quadratic function. So that's y equals x squared. Okay, y equals x squared. So that's good. So did you notice that there was there's different end behavior when we talk about these two functions. So for example, okay, I'm going to zoom out quite a bit. Now the graph, as x approaches a really large number, the graph races towards infinity on the y, right? So if x equals 200, y is going to be 200 squared, super large. As x equals 1,000, y is going to be 1,000 squared, right? So, all right, so this is what happens. The y values get very large as x approaches a very large number here. And also, as x approaches a really, really, really small number, like negative 1,000, the y values are also going to approach a really large number, because any negative number squared is still a large number. So that's a specific kind of behavior for this graph. And if I went back to y equals 1, okay, it changes a bit, doesn't it? As x approaches infinity, as it gets going farther and farther to the right here, the graph goes to positive infinity, but not quite as quickly as the parabola did, right? The parabola was pretty narrow, so those values got up pretty quick. So 800, the y value is 800. On the parabola, the y value is 800 squared, so it's quite a bit larger. But the big difference is down here, the end behavior, right? As x gets smaller and smaller and smaller, or larger negative, the y values get smaller and smaller and smaller, or larger negative as well. So those are two specific end behaviors. Okay, so what happens if I change this, instead of x, okay, through x squared, but what about x cubed? So watch what happens, and it's pretty narrow here, I guess. Let me zoom back in. So as we approach x cubed, okay, so let me just go back here. So there's 2. All right, so as we approach x cubed, 8.93. Okay, so there's x cubed. So this is, wow, if you look at this, this is sort of like the parabola in a sense, where it kind of comes down and then it starts to curve, right, to hit 0. But instead of going back up like x squared, it goes down. But, I mean, wow, this is almost like a parabola, isn't it? If you could flip this part up. It's not. It's also kind of like y equals x. Like, it's kind of almost like a straight line where it kind of does this thing, right? Down, up. Okay. So there's different types of behavior at the x-axis, but what we're focused on is end behavior. So this graph, as x approaches infinity, it sort of terminates in the first quadrant. Remember, this is quadrant number 1. And as x approaches negative infinity, or as x gets smaller, it's in quadrant number 4. 3. 1, 2, 3. 1, 2, 3, 4. So, having said that, let's just pop back to our notes here real quick. I'll maybe make those bigger. So, the behavior of the y values of a function as the absolute value of x becomes very large. So that's x approaches infinity or negative infinity. Compare the graphs within each from step 1. Okay, so we kind of did that, right? X to the power of 1, x to the power of 2, x to the power of 3, right? And so the end behavior depends upon the degree, okay, and so on. And we're going to also take a look at these other parts as well. Okay, so the degree, we talked about that. The constant term. Notice that for a polynomial function, the constant term is the Y-intercept. So watch this. I'm going to add another variable. Let's make it b. I'll make a slider for b as well. So if b is 1, look at what the y-intercept all of a sudden is. 1. If b goes up, right, that just moves that whole graph up. 5. There you go. The y-intercept is 5. So what if I have a different polynomial function like y equals x squared? Well, again, you know how that works. As b gets larger, so does the y-intercept. Smaller, smaller. So the constant function, even with, let's go to 4. We haven't really touched 4 yet. So 4 is kind of like a parabola with kind of almost a square bottom. It's not square, but it's pretty flat there. And so the constant, again, moves up, moves down, and so on. Okay, so look at what 5 is. 5, again, that mimics the cubic function a little bit. Okay, 6. Oh, look at that. 7. Wow, are you seeing some patterns here? 8. 9. Okay, see that? 10. Okay, so yeah, so now we're seeing some patterns here, right? The even degree functions sort of look like, a little bit like what? Now this is not looking like it, but it's sort of looking like the what? The parabola. It's kind of got that general characteristic. And that means that the end behavior, so if it's opening sort of upward, the end behavior is starts in quadrant 2, you could say that, it starts. End behavior, one end is in quadrant 2, the other end is in quadrant 1. And again, if I just run through all the even numbers here, you see, the end behavior is the same. They end in the same quadrants. Even if we were to move this over, okay, so even if we were to move this over, I don't know if I want to do that here now, but if we were to move it, I guess I should. Okay, let's see if I can do this here. So if we went to, let's see if I can get in there, x minus 5, with a bracket. Okay, so you see this? See how the function is moved over? Okay. If we do this, you might say, hey, look, the end behavior is both ends are in quadrant 1. Well, you would be sort of incorrect, wouldn't you? Because if we zoom out enough, you see that, hey, this goes up forever, but it also goes left forever. It doesn't go very fast, but as x gets, increasingly, the absolute value gets increasingly large, then they creep left and right, okay? I hope this is making some sense. So even if it's moved over, if you zoom out, you're going to have similar end behavior. Okay. All right. So let me just skip the last part. I'll come back to it. But here we go. These are the different kinds of functions. So a constant function is a straight line. We know that, right? The end behavior, okay, it extends horizontally. So it could be 2 and 1, quadrants 2 and 1. Let me just show you those quadrants here again. So this is quadrant 1. This is quadrant 2. I use Roman numerals as well here for these. And 3 and 4. Okay? So here's the 0, 0. So this is quad 1 and so on. That's quad 2, 3, and 4. So it extends horizontally. So depending on what the constant value is, it goes from 2 to 1. The end behaviors, 2 and 1, or 3 and 4. The linear function is a little more predictable. We talked about quadrant 3 and quadrant 1 for y equals x, or y equals 2x plus 1, and so on. We talked about the quadratic. This would be, so 3 and 1 here. This is 2 and 1, right? What affects that, though? What else affects that? For example, what makes the parabola flip upside down? The a value, right? Okay, so the a value, before we get to this, let's go back and take a look at this. The leading coefficient. So y equals, if we had 2x squared, this is the leading coefficient. It's the coefficient on the leading term, or the term that carries the degree of the polynomial function. So if this is positive, it opens which way? Parabola opens upward, right? If this is y equals negative 2x squared, the parabola opens downward, right? So that's going to affect the end behavior. Quadrants 1 and 2, or quadrants 3 and 4. All right?